Okie dokie, here we go again. Another live chat. A live stream, rather. I'm gonna wait for some people to turn up before I get started. Otherwise, the show will be over. Bum, 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 bum. Yeah. Seems like everybody's asleep tonight. Everybody except me. Must be Friday morning. Oh, g'day Mike. Welcome. First person to break the ice in the chat. G'day Metaman, yes, you're second, and Lynn comes in at third. Oh well, good start, 3. Took a little longer this morning than normal, but like I said, it's probably, well, it's almost 1:30 in the morning here. 7th, well, second to chat. Second to chat, that's what matters. Yes, Friday morning, and it is technically Saturday morning here now, so... Alright, well I might get started. Basically the idea tonight, just for something a little bit different, is many of you probably already have, use, or whatever, when you're dealing with iPhone batteries, you have one of these type charger brick units. You charge your battery up to 4.2 or whatever volts, and yeah, just to see if it works okay. But then sometimes you don't really want to store your batteries at 4.2 volts. It's with lithium-ion polymer, I should say, they don't like being stored at 4.2 volts for a long time. If you sort of consider these cells a bit like a latex balloon or something like that, if it's kept at a stretched state for extended times, it starts to fatigue and have some issues. So ideally with lithium polymer batteries, you store them at around about 3.7, 3.8 volts. Now, you could use this particular unit and then you can put a load on it, like say a light or something like that. But the trouble with doing it that way is that if you get distracted, then this thing will just keep discharging until it's basically below the storage threshold, and maybe, depending on the electronics on here, may well actually damage the pack if you go below 3 volts too much. G'day Amy, Greg, MacVision 3D, and Muservo. Thanks for the open board view software. Thank you, fantastic work. You're welcome, Muservo. Well, and also thanks to Chlorodite for producing the original version, and Pernov for putting up with all my crap while I did the new version. So the real problem we've got here is if we want to discharge these batteries to a safe level, we need something that's intelligent enough to cut off, and if we don't want to have to use a phone or something like that, we want to use a constant drain. We need to build a piece of electronics to do that. Now, these days it's easy enough just to use a microcontroller, even a 6-pin AT-Tiny 5 would do it, or AT-Tiny 10. Easy enough, you just sense the voltage on the pack and have a MOSFET going to something like a 10 ohm resistor like this, and when it gets to the voltage you want, boom, you cut it off. But about 11 years ago, when I started doing manufacturing for model aircraft, I created this thing here, a thing called the Lipo Normaliser. And in model aircraft, we often have packs that consist of 3 cells in series or 2 cells in series and whatnot. So I created this device, and it's all using just there's no micro blah blah blah. I can't speak today. There's no microcontroller in it. It's just all discrete logic and components. So I ended up. This is my first creation, and it's a 3-cell normalizer, and you would plug your lithium pack into here. This would be the charge or monitoring port that they would generally come with. And as each cell would reduce down to the cutoff threshold, they'd get shut off, and that was it. So you could leave it on there permanently, pretty much, because I had something like a 1 microamp, or maybe about 100 microamp quiescent current, so it was no big problem to leave it there. Hey Ray, Slarty Bathus, I can't say that now. So that was my introduction to manufacturing for model aircraft equipment. Funnily enough, this particular version didn't even work properly. There was a trace that I did not connect on the design, and yet it still did work if you had it at about 25 degrees centigrade. It would cut off at the right point, and that was just pure luck, because it just happened to be that the transistors I used would cut off at that temperature. So anyway, I found that out pretty quickly, redesigned it, and did my recall and sent people out the new version, which is this one here. So that was a pretty good start to the whole modeling scene, putting out a dodgy product and then having to do the whole recall. So I covered all my bases in one shot. So we're going to build just one cell for this, and then we're going to attach that to a USB plug, so that we can plug into the side port of this, and it should discharge down to the right voltage. The only trouble, of course, with this is that those LEDs across the top, their drawing are probably about 15 milliamp, 20 milliamp, so it could still run a little low. The design of this is a little weird. I'm just going to switch you over to the... No, wrong one. There we go. I'll just minimize this. Okay. So this is all 3 cells, and they're just copies of each other. So we'll just have a look at one cell. Basically, the principle is, initially we have, my god, I can barely even remember this myself. We have a voltage sense here, which is actually, this here is a TL431. I used to have a Zener diode there, but the trouble with Zener diodes is below 5 volts, 5.6 volts, they have what we call a very soft knee, as in, knee joint sort of thing. And what that refers to is that the cutoff isn't very sudden. The ideal diode, Zener diode, it gets to the cutoff voltage and then instantly starts conducting. But in real life, Zener diodes tend to be a little bit mushy. So the first revisions I had used Zener diodes, and it was just a nightmare. There's too much temperature variances in there, and the softness of the knee was killing everything. And so I upgraded to this TL431, which is sort of like a digital Zener diode, programmable one. It doesn't conduct a lot of current when it decides to conduct, but it's good for doing sensing situations like this. So we set that up along with this here, and basically it will end up, when there's power, it will pull this pin down if the voltage is above the threshold, and when that gets pulled down a certain amount, it ends up turning this on, which of course conducts the current through here, and that feeds back into the base of the PMP, which is done because we need to create a hysteresis loop. Because otherwise what will happen is, as it approaches the threshold of cutoff, as soon as you cut off the load from the battery voltage floats back up, which would then immediately turn the whole circuit back on. So you'll end up with this high-speed oscillation. In some ways, it could be considered a feature, but I didn't do that. So the whole feedback concept is that it puts a hysteresis loop in there, and so it gives you a broad going on or going off change of thresholds and so on. So it's a bit of a tricky little circuit. It sort of bends the brain a little bit initially when you're going through and trying to piece out how it works, but it does the job, and it was cheap. Hey Chris. So, and the board layout itself, is it here? As you can see, it's just 3 copies of the same thing. And you're probably wondering why I've got these odd little traces here. The reason being is that we've got about an amp or so, a little bit over an amp coming through on these traces here, going to the load resistors. And because of that high current, relatively speaking, it would manipulate the sense voltages. So anytime you have a case where you need to sense or detect a voltage or a current, and you don't want it to be overly influenced by the power that's going through, you have these finer traces that come off from the main point, and that way, even if the voltages drop 0.1 volt extra over here or whatever, it doesn't interfere with the sensing process that you're going through. Spotted your cat on the Shotcut forum. Yes, Motorman. Yep. I'm over there on the Shotcut. I'm trying to see if I can get them to squeeze in a couple of little extra features for me. I'm actually very happy with Shotcut. Anyone who has tried to do video editing in Linux will know that it's basically been a complete and utter bollocks until Shotcut came into the scene, and finally there is a product now that, while it lacks a certain degree of features, it is still a stable product. It works well, and I can only hope they keep improving on it, adding more features. My mic is always so low. Let me see what I can do for you there, Chris. Maybe it's just me mumbling. It might be because I killed the controller. There we go. Input devices. Let's see. Let's give me another 3dV gain. Okay, Chris, is that any better? And now we wait for YouTube to actually get around to transmitting all the signal and letting Chris know, and then he can give me the feedback. Oh, come on, CryJ, no one cares about productivity, come on. Wanders off to her solar charger. Are you making a solar charger, Amy, or are you installing one, setting things up? Sounds good? Marvellous. Okay. I'm not sure why when I closed this down before, it was open in the previous streams. I'm not sure why when I closed it down it killed that 3dV drop. It should have been persistent, but oh well. There you go. Crappy open source software for you. And I'm one of the creators of it. Alright, so basically now I'm just going to build this board. It takes a whole 15 seconds. Yeah. YouTube chat powered by only the best hamsters. I'm just doing some research. I can do both. Oh, what are you researching? Or don't we want to know? Just going to switch over to my... That's it. That's better. Slowly getting the hang of this whole OBS thing. What? I'm just cussing here right now because I can't seem to find my values. Interesting. How you make your wing longer? Yeah, okay, well done, well done. Ah, found it. Yo, now it's a mess. Top names, bottom names, apply. Okie doke. I suppose I better turn on everything. Soldering on. And tonight, to try and cut the audio of the audio report of the fume extractor, I've got it on an adjustable voltage. So instead of running at 12 volts, I'm going to run it just under 10. Okay. Finally just coming up to temperature. Okay. Well, that's not freaking doing anything. That's just... looks like I'm going to have to go up to... let's try that. Voltage. Okay. Gave it another volt. The most frustrating part of putting components down is trying to get the little bastards to actually line up properly. Hey TCRS, you also got nothing to do today. Oh, crap's sake. Let's just finish off with flux. Makes everything stick. Just a annoying bunch of stickiness everywhere. Far out. Come on. Yeah, Mike, I'm gonna be ordering a hydroponic setup, and it will be the same idea. Basically, the loud part goes elsewhere. Interestingly, these tweezers were purchased at the same time that I originally did these manufacturing, which puts them at about 11 years old now too, as a consequence. Oh my god, I feel like some days I can't decide whether I want to use tweezers in my left or right hand. Mine gets extracted into a tube on the roof. Mike, and what happens to that exhaust? Or shouldn't I ask? The only thing I worry about with the fume extractor hydroponic system I'm thinking of is, given that I have incredibly high electricity bills relative to the average in this neighbourhood, and that the lights are on until the wee hours of the morning every morning, and the fact that I'm buying hydroponic extractors and whatnot. I'm kind of half expecting a raid. And then they'll see all this stuff in here and they'll be like, I don't know, we came here for a drug bust, we've decided you're a terrorist. Should be interesting. ZX840, yes, it was originally a 3-cell lithium polymer balance. Well, actually, not strictly a balance, but it was a normalizer, as in it would bring the voltage down to about 3.75, 3.9 volts, so you could then put that pack into storage. Because back then, I'd have a couple of dozen packs just sitting on the shelf at the very least, and I didn't want to be killing them by having their voltage sitting around too high. Crap, wrong one. Mike, I would like to do solar. There's a couple of complicating factors on that, but yes, I would. Damn it, I lost my little wedge. Putting something like 5 kilowatt panels on the top of this roof, and this roof can handle it. This roof has room for probably about 8 or 9 kilowatts, easy. So I'd like to do that, but there's the investment cost and just the ownership of the house complication situation. But if that wasn't the case, then yes, I would certainly be getting myself some solar panels on this place. This project is also interesting for me in respect for the fact that it is one of the very, very few projects where I use BJT transistors, or just transistors as most people know them. In almost every other project I use MOSFETs. I've just never been a fan of BJTs. Probably a lot of that stems from the fact that the maths surrounding biasing BJTs and just used to drive me up the wall at university. I was like, oh man, all I want to do is just turn things on or off. Oh crap, wrong one. Whoops. So yeah, I get frustrated with that. I'm tempted to just hot air this after I'm done, because that was a really shitty, excuse the language. You stuck there? How are you stuck there? You're not even on anything. Come on. Oh. Yeah, you're intact. Where'd you go? No, that's one very dead resistor sitting on the tip of the... There was one drug crop that got busted tapping directly into the substation next door. Yeah, I've seen them do that. That's pretty crazy. Okay, that's another 470s. So I get my 470s back. Yeah, they can be really resourceful, those chaps. Do some damn crazy stuff. I'm just not feeling as if I've got enough heat in this tip today. Seems to be enough to knock those resistors around. It did, yes. Very sorry about that, John. Unfortunately, there's a very real limit of what can be done here right now. Does not help that my extractor is running along. Oh, flip's sake. Well, I've just broken the latch off that there. I'll have to transfer those to another container before I lose them all. And then I'll have 12k resistors littering my floor. Now this design is supposed to have a small power inductor for the input, but because I'm only dealing with one cell, it's not going to be required. And it would appear as though I was supposed to have a 0805 size there. Oh well, I'll hot air and push that across. How to turn a crappy soldering job into something that looks more professional. Slightly. Can't touch that for about 10 seconds or so. In my experience, SMD parts don't litter, they just disappear for good. Yeah, it's quite true. Once they drop off the bench, it's like, well, nice knowing you. Bobby, yes, and I'm pleased to report that I received my RMA assessment today from my supplier, and collectively I will have enough money. It's just going to be a bit interesting because it takes about 2 months for the YouTube donations to get through to an account. It's just the way it goes. And also with the RMAs, they are store credit only, but fortunately I do go through around about the amount they refunded me every 2 months or so. So everything lining up, I'd say come late July maybe or early August, I will finally be in possession of what I need. Stuar or Frel. Fast. Oh my goodness. Forgot about Farscape. Um, one of the characters that was in it, a girl, I think. Was there any one girl? I can't remember. She lived on the island just across the water from where I pretty much grew up and went to school. And interestingly, damn it, I can't remember his name now. That chap that's been holed up in the embassy in London for the last 7 years or so, he was in the grade, I think it was in the grade up from me at school. So yeah, he went to my school. The name just defeats me right now. Looks like I missed a bit of solder there. I never quite got Andrew Denton's humour. I mean, I watched a fair bit, but it just couldn't quite, what was it, Money or the Gun and things like that. On the other hand, I must sadly confess that I would spend quite a few nights laughing at The Big Gig. The Doug Anthony All-Stars were a bit weird, but yeah. Okay, turn that off. Okay, well theoretically this might work. I genuinely don't know what it's going to be calibrated to. Oh well, we'll find out. Julian Assange, that's the one. Thank you very much. Crap. I have forgotten which bloody pin on the USB is positive. Oh well. Let me just test with this. Just say the WikiLeaks guy, yeah. Yeah, so it was a bit of a shock to find out that he went to the same school as me and the year, just like I said, a year or two up. Because people were saying, oh, do you know Julian Assange? And I'm like, who? And then I found out, and I was like, oh, yeah, fancy that. I said, nope, don't know. Okay, well this is already telling me what I want to know anyway. Okay. This is not going to be the most ideal way to configure this, but we're only doing it for the sake of testing, of course. Okay. Oops, sorry about that. And looks like I need my soldering iron and everything back. Let's see. Claudia, I think it was Claudia, yeah. Alright, so this here is our ground, and that is our first cell. So is that audio any better now that everything's switched off? You may recognize this cable from the other night when I did, or the other video where I did the USB data recovery. Strictly speaking, pulling 1 amp over these poor wires probably isn't the best or nicest thing to do to them, but again, like I said, it's for testing. I'll do. Nice to see you doing work for yourself. Yeah. Stargate, that's, yeah, okay. Alright. I'm just knocking that camera around too much tonight. It's late, that's my excuse. Alright, so here we go. So currently this battery is sitting on, it could be a bit low, and you can't even see that. There we go. What do we got? 3.78. There you go, that's easy to see. So now, in theory, I am either going to get a bit of an explosive output, or I should just get a green light. Let's hope for the latter. And we get nothing. Marvellous. I'd say that the pack is probably too low on the voltage. I don't think it's shorting out, because otherwise the LED the charger brick would be having an absolute fit. Minus 3. What? Did I honestly to God get that backwards? I did too. How? Apparently that's backwards. It's kind of weird. Didn't expect that. And this, ladies and gentlemen, is why you don't do this sort of stuff in the wee hours of the morning. It's pretty impressive that that camera was still picking up everything in spite of it being quite dark. Well, I'll probably truly effect it up now anyway. Truly, did I? Now I'm all confused. Thank you very much. Thank you very much. My leads are in the correct order. And I am seeing 3.86 volts. But I probably blew the living daylights out of something. Got 3.3, 0.19. 3.8 is correct for that. Hello, how can you be -2? You've been pulled down. You've lost your brains. .47. Yeah, that's doing its job. .47, 3.3. Well, maybe it is a case of it just simply being a bit low. I'll go get a better battery. Hello. Oh yeah, there we go. They're kind of fighting though. But, I think I'll change that LED. The big trouble with these sort of circuits, being all analog as it were, is that they are substantially more susceptible to component variances. Oh crikey, no. How about a red? So you will perhaps design it around one thing and it works fine, but then your supply runs out, so you go get a new batch, but you find, oh, you can't get that one anymore. So you go, oh, that's okay, and you check the spec sheet and you think you've got something that should work, and so you replace the parts and then you find it doesn't work anymore. And it's all because of that one part that has sufficiently different specs. It's enough to ruin everything. Whereas with digital projects, yeah, microcontrollers and whatnot, you got a lot more room to play. Yuck. I had to touch that. Yes, the rumour is quite true, and it's only because of the extraordinary generosity of people who have participated in the last week or two. Something that I genuinely was not expecting. Ooh, there we go, we got fire. Okay. So I may have to just get a newer battery because I'm not even sure if this 4S pack even works. Oh, there we go. Yeah, we're working. It was just a case of the LED was come on. Oh, that just went out. So it looks like the threshold's about 3.75. I'll go get a more charged battery. Just give me a moment. Oh, Southern Micro Soldering. Don't recall seeing you here before. My apologies if you have been and I just simply didn't take notice. Alright, there we go. So this is starting out at... I'm going to turn this around. Got a split just there. Okay, so we're starting out at 3.89, 3.9, damn it. Yeah, 3.9 volts. So theoretically this thing should cut out at about 3.75, so we don't have too far to go. This is a pack that I had to repair today because I had a customer contact me and say, I need a battery in half hour, I'm heading off to Townsville, which is the town next to us, of course. And I said, sure thing, okay, I can do that. And I only had one 5S, 5C pack left. I went to use it only to find that the plastic assembly holding oh look, we're starting to oscillate a bit there now. And she is pretty much out. That's a little high, 3.95. Let's see what it really is on the battery. These LED, these charge boards are notoriously bad for accuracy. I mean, they do the job, but I wouldn't trust them for being accurate. 3.99, I'm way too high there. So to bring that down, I'm fairly sure, let's pull that out, fairly sure I have to change, look, I often put a 10k there or 12k, I think that's what it is. You may notice, I don't know if you can see it in that camera shop, but a lot of these pads have duplicates, and the reason being is, again, like I was saying about tolerances, it's not unusual, like when you get the new batch, to need to adjust things. So sometimes you can't get a resistor that's going to be exactly what you want it to be. So you end up having to put two together, and one of them sort of trims out the other. So that's why all these have two pads. What? Oh, try to solder with a cold iron. That's not going to work. Southern Micro Soldering. I'll watch your stuff after it gets posted. Oh, sorry about that. And I know lately I've been kind of hogging the whole live broadcasting thing. I gotta admit it is easier than doing edited videos. Though if I do have a particular something unique that's come up, then I will tend to make a edited video, particularly if I feel like it hasn't already been in my existing set of streams or videos. Like the other day I did the USB stick recovery. Thankfully just needed a bit of soldering. When the customer told me about that one, I was kind of dreading they had broken things more severely, or worse, it was a monolith. Those monolith batteries, USB sticks, just, oh, the hell. If I get one of those, I just send it off to someone else. So, no thanks. 5J5S, 398. Let's try this again. Nope. I must have trimmed that the wrong way. Crud. Alright. Come on, come on. There you go. Looking for my mouse. Cancel. We'll try 10K. And unfortunately, this is what I would have to do every time I got a whole new batch of parts. So after a while, I ended up just buying massive reels of parts, so I wouldn't have to go through this too often. And this is definitely where traditional BJT transistors just completely suck. Because those little buggers just wobble everywhere. No, still no go. What the flip did they do? No op-amp on the... Nope. Well, ZX, there's the TL431, which I suppose you can sort of consider it as that. I use the TL431 as my reference. I really need to learn to leave more notes for myself here. Okay, cancel. Usually isn't you. I need a more aggressive. Well, I'm going to switch over so you guys can see this. Okay. Basically, I need to have a more aggressive pull down here. So I've got two choices. I can reduce the resistance of this, which will in turn basically cause this to have a greater relative voltage, and it should squeeze open the gate, the base, sorry, because this is a PMP, so we need the base to have a little over 0.6 volts across it. So this is the one I need to reduce. Which is that one there. Alright. And the mid one. So I'll put something like a 12k resistor across those pads. Now, of course, the counter issue then is that it will take longer to turn off, of course, which is what we want. And of course all this has a temperature coefficient to it. So you may set it to what you want at 25 degrees centigrade or whatever, and then you send it off to someone in, there we go, that's what we wanted. So we're back. Oh, you can't see that. Now I know how Lewis feels. There we go. Turn that off so you guys get a chance of seeing it, and we'll see where it what the flip, it's cut out already. Come on, did I leave? I did. Talk about irritating. I can tell you I spent way too many hours. What? There's nothing there. There's nothing there. I spent way too many hours trimming these things. And this is when using a microcontroller becomes so much nicer. Certainly if I did this today, I would just use things like probably a tiny 5 or something like that. You'd barely need 100 bytes of code. Or you could use an op amp, a different kind. So here we go. Alright. Looks like that's driving pretty hard. Okay, now let's have a look now. ZX840 says, 2.5 volts, and yes, although I suppose strictly speaking it's 2.48, but yeah, who's counting? It's 2.5 as far as I'm concerned. And these are 1% regulators, TL431s. So let's see how we go. If we get below 3.8, I'm happy. You watch, it's probably not going to pull out until about 3.6, in which case it's too far. So, surprised you didn't put dirty old pot on it. Yeah, definitely not. The biggest thing in this particular job, by God, I look fat in this outfit. Anyway, was cost. Like I said, this is a very good first project for me in terms of electronics manufacturing, because I had to, learning the schematic and the PC board layout was the easy part, given that I'd already done it plenty of times before, but I'd never gone into the manufacturing process before. And fortunately there was a person who saw what I was doing and gave me a good hand. The Iceman or something was his name, on IRC chat. So if he ever watches this, I still have to thank him for all the help he gave me. Anyway, needless to say, he taught me about the necessary requirements for submitting circuit board layouts like this to manufacturers, with all the Gerber files and things like that. That's fine. Yeah, we're going to do that. And keep in mind, this was over a decade ago, so it wasn't turnkey sort of situation like we have now, where we can just send something off to Seed Studio or whatever. We're still cutting in a little low there, 3.8, but I'm gonna let it go. 3.8 is still a perfectly acceptable storage voltage. Uh, and this should be nice and hot. Yep, can almost move my finger. Almost. If it was at 4.2, it really would be burning quite hard. So yeah, going through the process of getting these boards manufactured, particularly on a small scale. At that time, I think Gold Phoenix was one of the only regular, reliable producers. Um, so I had to go through all that process. So that was one part, and the other one was, of course, trying to minimise the bill of materials cost, and that is where this design became quite useful because at that point. Uh, Even the smallest microcontroller was perhaps $1.99 or something like that, and that was the AT Tiny 13 for me. And if you consider there's three of those on there, plus all the associated parts, and the power resistor, and then of course the um, acrylic case, all of a sudden it became impractical or just not financially sane to try and sell this thing at commercial quantities. It just wasn't going to happen. So yeah, I had to learn about minimising the costs, and that's where going this way went really well because the TL431 was I could get them for about 25 cents a piece, and all the other bits and pieces were fairly cheap too. Um, Hello, Duarte Milo. So, Chris, what's the purpose of discharging the cell? Uh, if you store your cells at anything too high, it if they're there for a couple of months at 4.2 volts, whatever, it does tend to degrade them. Likewise, if you store them at anything below 3.3 or usually 3.6, they degrade again in a different kind of way. So you like to store them at about 3.8, 3.7 area. You'll find if you get fresh LiPo packs from anywhere, from a proper manufacturer, they will all come supplied at about 3.8, 3.9 volt charge. So yeah, store them at acceptable voltage to reduce the stress on the pack. So I'm going to call the flashing a feature. It was a very intentional feature. So, well, that's good. The flashing. I'm trying to think, it should sort of slow down over time. I have some really nice photos of this in the green in its new acrylic case. Wish I could just find them. Actually, I might just do that. Give me a minute or two. I had people buying these things purely as art pieces, which was rather strange. LN3S images. Ah, here we go. And funnily enough, from my own website. Who would have thought? Nope, nope, no. Oh, glory! We do not permit the use of robots or crawlers on this server. That's great. It's my own damn server. Oh well. Visit page. There we go. Ah, marvellous. Have a look at that. Alright. Okay, you can see the flashing is starting to become a little more intermittent and less frequent, which is good. It means it's approaching and you can see how the voltage of the pack is changing. So when it's under load, it's sitting at, what is that, 3.88, 3.9, and then you take it off the load and it comes up to 3.2, up 9.2 or whatever. Yeah. Slattivart fast says, wouldn't it be helpful to have some cap reducing the flashing and leaving the discharging on a little longer? It's not really required because this is basically, it's approaching the cutoff, it's asymptotically approaching the cutoff, as I would say to Jessa. So this sort of behavior sort of as expected. I can make it more aggressive with the hysteresis. Basically, I increase the hysteresis window size, but in a way, this is kind of effective. I like it. And I'm not manufacturing these anymore anyway, so as it was with the original, well, the final release of the manufacturing, this is pretty much what they were doing. A little less up and down, but still pretty close. With speed up getting to the right voltage, well, it would speed up things a little bit. However, most of the time people were using this, they would just plug it in at the end of their day of flying their model aircraft, and so they'd come home and hook up their battery packs to these normalizers, and in the evening come back and just disconnect everything. So speed wasn't really the main issue. Not to mention the fact that we're only going to be drawing about 1 amp, not even an amp, come to think of it, at 4.2 volts. So if you had something like a 4400 milliamp hour pack, it's going to be going for a couple of hours anyway. So I can't get enough charging voltage to turn on the regulator. Oh, how much do you need to turn on the regulator, Amy? Is the problem that it's not a low dropout regulator, or are you using linear or switch mode? Okay, just turning off everything because we're pretty much at the end of it. So it looks like it's going to settle out at about 3.9. That's tolerable. I would like it a little bit lower, but I'm not going to keep screwing around with these resistor values all night. You guys get the idea, and that's what matters. And it was just demonstrated. So this was my first commercial product, and after that I've produced quite a few others, all mostly model aircraft related. And then that sort of came to a crashing halt when everybody was able to start direct buying from China, and China started direct buying from me 1 or 2 copies, and then I'd see them a couple of months later available for less than what it cost me to buy the parts, which is always amusing. So, yeah, someone asked, let's see, what was it? Rosen Georgiev says, what does the logo on the board mean or represent? Okay, there is a story behind that logo. The initials of my name are PLD, and I wanted a logo for my business. This was probably, well, it would have been 20 years plus ago. And so I thought, I spent a couple of days trying to come up with something, and yeah, just the spinning pinwheel kind of worked out nice and clean. You can see it probably at the bottom of my videos as well, the bottom right. It's up there by YouTube. Agreeably, I've only got the 3 letters, so there's a 4th leg in there. That doesn't seem to make sense, but yeah, it sort of fit. I didn't really think it had to be absolutely perfect. It looked weird with just 3 legs, so 4 it was. 5 volts 7805 charging. Oh yeah, if it's the original 7805, my god, yeah, they're not low dropout. So you're gonna need at least 5.5, I'd say. Oh wait, yes, 7805. You're gonna need 6.5. That's why I use the LM1117s and things like that. They're a little more unstable, but you just put like 10 microfarad or 20 microfarad either side and it's fine. That said, it's not much fun when your LDO regulators decide to start singing and dancing when they go into self-oscillation. I'm looking at an open source Arduino RX5808 diversity receiver. Is that, Stray, is that one of those software definable radios or anything? I was thinking of getting one of those at some point. Or have I completely misread what you mean by diversity receiver? Probably have. Excuse me. Yeah. Okay, well that's stopped and dead, and I also know now that my battery works, so that's cool. If I really wanted to, I can. Yeah, let's get this out without knocking everything. I could put this unit between this pack, the board plug-in, and the discharger, and then I'd be able to track how many milliamp hour are drawn from the pack. So give you an idea then of how good the pack is at retaining the charge as opposed to just burning it up in itself. I am seriously considering creating a proper cell testing board where what it'll do is it'll accept charge, it'll keep track of how much that is charged, and then it will discharge and see how much it'll do. If you already have something like a model aircraft lithium pack charger, one of the intelligent ones, that functionality is already there, in which case all you'd need is just an interface board to go from these connectors to banana plugs. So FPV video for 5.8 gigahertz. The module is set for 8 channels from the factory, but I delit it and removed it. It becomes 40 channel, 48 channel, 70 channel using a pseudo peripheral interface to determine the channels. Get one and play with it. Oh, yeah, more things to do. There's a lot of projects I want to try out, things I want to do. I'm a little disappointed I missed out on the whole quad thing. At the time that I was finishing up with my model aircraft stuff, quads were just starting to become a thing, and I was getting involved with the controllers. And back then, we were like pushing the 18 mega 88s or 168s right to the limit, and the 3 or 6 axis or 9 axis sensors were pretty dodgy. You know, they didn't really have the resolution you needed, the precision. So now looking at all these commodity commodity quads just being out there for $20 or something is quite amazing. I really am happy to see that it's gone that way. What I want to see now is them making quad racing but about 100 to 300 kilo class, just for the hell of it. Hi Firephone, almost just finishing up here, but I can drivel on for a little bit longer. Sort of at 2:30 again. Yeah, it's getting pretty hard to wake up in the mornings lately, but I need to because customers are coming in and they're wanting their stuff done. So, well, that was the other thing with the board design. I'm going to just flip over now that we're done here. Alt 2 through. What's going on here? That's interesting. It's changing my screen as well. Oh well. With the design of the casing for this board, because I'm dissipating around about 10 to 12 watts of heat off these resistors, the acrylic does a pretty good job overall, but you know, it was going to get soft if we kept it too close. But at the same time, we also had to watch out for human fingers touching it, so we couldn't make these slots here any bigger than what a normal sort of finger could sort of touch down on. And then probably the most expensive part of this whole setup were these metal standoffs. They're about 10 mil, I think it was, and it would cost me around about $30 for 100 of them, and of course I need 4 for each board. So that was a bit expensive. The acrylic casing itself was fairly cheap. I did that up in a CAD program, sent it off to the laser cutters. It was a pain in the butt to assemble them because you'd have to peel off the paper obviously and polish them up. It was a good exercise in optimizing usage or reducing wastage. All these, you probably can't see them too clearly, but these little plastic standoffs that sandwich the board between everything, they come out of these large bays here. So I had them cut out in there on, yeah. So yeah, I didn't make $1 million obviously off this, but it was very good for basically getting your feet wet in the market, working out all the weird challenges you got to deal with. And this extra slot here, that was to stop the transistors getting too hot, because they are running at the limit pretty much of what they can do. So, alright, let's have a look at chat. Making something to talk to iPhone batteries to see if the communication is fine would be good. iPhones have a habit of going bad if the battery doesn't communicate. Yes, with that error 23, or is it error 25, error 26? But I know the one you're talking about, yes. I've got a few phones here that are suffering that as well. The communication thing isn't there's already software available that will do that, but it'd be nice if you could integrate it all together as one thing. And it'd be additionally nice if you could read off the serial number of the pack, given that it should be, if it's a good pack, it should have that encoded in the one wire, well, they don't call it one wire in this, but in the gas gauge itself, it'll have a unique code. If it's a horrible clone, they'll probably all have the same code. So, iPhone, I was wondering if you could give your customers a flyer to sign which says that you own their stuff if they do not collect in 45 days after repair, or you charge for storage. I can do the latter. I can say that the storage charges, but I can't do the part where I basically claim ownership of it by default, mainly because I can't take away their existing rights as a consumer. So it's unfortunate. Even if they sign it and know full well, they can always just go back to court and say, well, look, this contract effectively is null and void because it's signing away my rights. Let's see. Chris Long says, I think there will be a big market for you if you did something specialised tool for Apple repair. Open board view is a good start, very helpful, but you understand a fair amount of that could help. And very helpful, but you understand a fair amount of that could help make repairs and testing easier. Yeah, I agree, Chris. I have to admit, I do see myself sort of falling into that role in amongst the repair community. It's been my strength, as it were, or as it was discussed the other day on the channel, my fort, to create these sort of diagnostic tools and things like that. So while I will do repairs quite a lot, obviously it keeps the money rolling in every day, I will tend to end up producing these sort of tools predominantly for my own use initially, and then I sort of think, oh yeah, maybe other people can use it, and then I'll look at manufacturing. Hey Rave, good to see you again. Thank you very much again last night. For last night, you know what I mean. So, hello Sanaka, I see you caught up for stream finally. I agree, the data read-off info, they make one like that runs around 90 or so. Okay, Chris, if you have a link for that, can you send that through to me so I can have a look? That's the other thing is, you have to make sure you're not duplicating what's already out there. I mean, I was thinking of producing something like these things, and likewise the power flex that you use as well when you don't have a battery and you just want to run off the DC power supply. And so it's like, well, no, why bother? They've already created this, and they've already created the power flex. There's no point, absolutely no point, doing anything like that yourself. You want to make $1 million, sure, you do that, you start out with 2 and you end up with 1. Yep, just thought you might want to program a micro to test incoming batteries so you don't succumb to the error. I agree. I mean, you're absolutely right. every week I probably waste a battery or two when I misdiagnose a TriStar or something like that. Or if I got to admit, if I'm trying to be optimistic and sort of go, it's not going to be the TriStar, it's probably just a dud battery. And so I stick it in there, and then 2 days later the customer's back and says, no, it's not working anymore. And because I've been a fool and used the command strips, the fake command strips, I end up wasting that battery. So because you know, I do not like ever reusing a part for another customer. Like even if I put a screen on a phone, and if it's just got the tiniest little blemish on it, I can't do it. I can't give it to another customer. I've got a fair few too many screens on my workshop that I'm going to have to send off to be refurbished as opposed to given to customers. I lied, it's 250. Oh, Chris, how could you? Oh, Union Repair, yeah, I know them. Ah, Sonaki, get your data right. Okay. Uh, let's see. What's this thing do? Let's have a look. Oh, nice. They've got a dedicated daughter board. That's smart. I do wish they made cheaper screen testers. I know you can get them, but they're always so expensive. It's just cheaper to find someone's second-hand phone and use that. I know it's more of a pain, but I mean, this looks pretty decent. I mean, for 250, I would want to. I mean, okay, it's all in Chinglish probably. Charge card, discharge card, blah blah blah. I mean, Chris, over and above and beyond what this offers, what would you be looking for? Because even at 250, you know, it's not a huge cost. 50 gigabytes per month, that's quite tight. I suppose you probably not want to watch streams anything more than 240p or something like that. Now, Rave, doesn't everybody call it Chinglish, or have I just been incredibly racist there? Probably the latter. At least that's what I always understood it to be referred to as. I mean, all the instruction manuals and things like that that you get, it's like, it's an impressive blend of Chinese and English. Oh, okay, Chris, right, I understand what you're saying. See, looking at that, I would say that's easily, you could easily burn about $5,000 prototyping and manufacturing. And I can tell you now, it definitely won't even look as good as that, at least not initially. They've got it's not the greatest. They have probably reappropriated this casing from some other project, but yeah, you probably will find over there somewhere there's a manufacturer that produces this whole outfit with the screen, and they've done a minor modification to put this board in there. So yeah, you could easily burn 5,000 developing something like that. English, okay. iPhone Amy was here earlier, and then she had some issues to go deal with the solar panel, I believe. Not really concerned about more feature. Right, yep, read that. My fault. If you just had software-based use, I agree, Chris. That would be. Glad to see you're thinking the same way. That would be the way to, how could you say, be competitive in this situation, rather than trying to replicate what they have. You go along and use the computer or laptop as a alternate interface. Definitely the way to go about it. I've got one of those O1B35T meters on the way. Yeah, I've got to get one of those as well, Stray. I think, and when I get it, I will produce a multimeter software. I know it comes with its own, I've seen its own, but it's Windows only. So what I'm going to do is produce one that will do Linux, Windows, and Mac OS. Do it, Chris Long says. Yeah. And Chris, this is how I lose all my money. This is why I'm dirt poor right now, because I keep doing stuff like this. So at that low ohms meter that I did, I think I burned about 3,500 on that thing. I just barely made my money back, which isn't good enough. But I keep getting suckered into doing things like that because it's fun. But yeah, I'll give it a go. Like I said, I'll just have to. The hardest thing will probably be finding a suitable source for these kind of boards that I can then daughterboard, use as a daughterboard on my own board. Firephone, if you look in uh, my descriptions for the videos, you'll see I've linked Chris and Jason, as well as Lewis and Jessa. I need to add more people, like TCRS as well. Yeah, my way, 3,500 is pretty cheap for developing a product like that low ohms meter. In fact, it's very, very cheap. Uh, and if you go for something like one of these custom molded cases and whatnot like this with a professional look and finish, easily 5,000. Just these Lexan front panels, those printed adhesive covers, they cost a fortune to get printed. I think the ones for the low ohms meter, it was about $600, and that was just the upfront costs. They gave me five for like a, how could you say, a thank you for being a customer. Here's 5 samples for you. That's all I ended up pretty much ordering. By the way, I'm Jason too. Don't ever call me that. I won't do that, Stray, since you asked. Hey, Penov. I don't know why, Penov, but I seem to always not quite see you when you come into channel. Anyway. Uh, so yeah, Chris, I'll have a look at that. I'll have a look at the specs and the features. It does seem like they're basically doing the same as what I was planning on doing. But as you said, it's a handheld device, and I would more likely go for a PC-based device, primarily because I'd want to be able to log the information such that I can always recall back later. If a customer comes back and says, "Hey, you put this battery in my phone and it's complete bollocks and almost caught on fire," and then you can go back and say, "Oh, I'll plug that in." You plug it in, you go, "Hey, this isn't on my list of batteries that I have had through this store, so either you're telling fibs or someone else has fitted a battery in there and it wasn't me," or something like that. It gives you that. It gives you the ability to audit what's going on a lot better. The TI based ones. I know the ones that it is. I can't think of it off the top of my head. BQ. I think it's BQ 25576 or something like that. But yeah, I know the ones. It's like a one-way protocol, but it's called a different name. The signaling is slightly different, but it's the same idea. Let's see. Rave TCO. I've been looking into trying to stream record. I'll need to grab a tripod for my phone and figure out how to stream from that, since I don't feel like getting a dedicated camera yet. Yeah, the tripod at least is the easy bit, isn't it? You just use those spring-loaded C clamps or something, and it sits on top of the tripod. That's easy. Getting it, the only way you probably be able to stream, I imagine, is if you find a piece of software that will do it within the phone itself, off to YouTube. The what is it? This Logitech 922 camera. I mean, the price 120 or so. I'd say it's worth getting it if nothing else, you can use it as a workshop recording camera later. Micro SD might be a good option. We're using for black box logging of flight data. I have thought about doing that sort of thing. The downside is it does add another layer of complexity, and yeah, maybe just consider an option, I guess. Parallel save the data. DroidCam. Yeah, I think I tried DroidCam once when we had one of our cats turn up when it was Australia. We didn't own it at that point, and we had to keep her locked up somewhere. So I put an old phone in the shed where we were keeping her locked up, and I think that was using that DroidCam. It did the job well enough. 3D printers are reducing prototyping costs, and laser cutters also. Definitely laser cutters. That was what I used for the acrylic situation. 3D printers, I wonder about that. I suppose, yeah, it certainly reduces the prototyping costs, and then once you've got it right, you can send off to get the injection molding done, which is incredibly expensive, actually. I suppose it is a whopping great big slab of aluminium or something that they use. Anything used, an ACG flight controller in quadcopters, flying wings, rovers. Most of the quads that I've been looking at for the building and whatnot, they're all using the STM32s. There's a few of them still using 8-bit, which is kind of cute. I'll probably end up doing 8-bit ones for nostalgic reasons. So, alright, it's now 8 to 3 in the morning. I probably should be going to bed. I know I said I should ages ago. But thanks all for jumping in. And it was a bit of a different bit of a job tonight. And I will be using this discharger. I'll clean it up, make the cabling a little more secure because it's already starting to pull out. I'll also increase the gauge of the wiring. This is I think this is about 30, it's close to 30 gauge, 28 or 30 gauge, it's not enough really. And I may even look at putting the USB plug directly onto the board so I can just simply plug it into the side of this thing. And that'll do the job for me. For now, at least it lets me know that the battery is working well enough that I can give it to a customer. Alright, thank you all, and I'll see you guys next time. Take care.